7. Okay. Now, picture this. If you will, you have magnesium who has 2 electrons in it. It doesn't want those 2. It wants to be filled. It either wants 6 more or it wants to get rid of those 2. So it can get rid of one of them here because this has an extra spot here. So that one can go here. Chlorine as well. Every single atom wants to have an outer shell filled. The valence electrons need to be filled, folks. Now it's happy. It's happy now. Mg and Cl, now Cl is happy, but this isn't quite happy because it has 1 left. Well, what can it do? Da-dee-da-dee-da-dee-da. What if you had another Cl that was hanging by? Another Cl hanging by. Am I right? That magnesium could share its other electron with that Cl. Ooh. Right? Follow me so far, folks? Good. Now we have 2 Cls, 1 Mg. How do you write the formula then? Well, I already showed you that already. It was Mg, one of them, so you just don't put a subscript on the 1. 2 Cl, so it's Cl2. That's how you write the formula. It's an ionic compound, MgCl2, and it's called magnesium chloride. I-D-E. I'd tell you over and over that anions, negatively charged ions, ionic bonds, pretty much any molecule is going to end with ide. IDE, okay? So, IDE specifies that it's a molecule. Got it? It's a molecule. As opposed to chlorine. Chlorine, I-N-E, is the atom of chlorine, or element of chlorine. Ide specifies that it's an anion. Now the cation, the positive ion, they don't bother with that because they're written first anyway. So, sum it up, here's what you need to get. Magnesium plus 2 charge needs 2 Cls to balance it out. Real life example here. I'll break this down and I'll insert a page here so you can see. You go to insert blank page. Okay. Situation up ahead here. Magnesium. Large guy, kind of happy. He's smiling. That's his smiley face. MG smiley face. Got it? Okay. Here's Mr. Magnesium. Now, Mr. Magnesium in his stable, chemically stable form will have 2 plus charges. Remember? He has 2 electrons. He wants to get rid of them, so he's stable. Well, that would make him a plus 2 charge. Real life here. Real life. Now, this happens sometimes. Mrs. Chlorine, she is a very funky looking face with a Cl there. It's almost like a sideways smiley face if you look at it. The eyes are closed, and then the smiley face, you can kind of see it. This is a, yes, just go with it. So she has a sideways face, and she is a lady, a nice lady there. That's her nice hair. She's beautiful hair there, yes, kind of like mine, yes. Anyway, Cl is a minus charge. Now, this guy, he's plus 2 charge. That means that he wants, picture these as wedding rings, if you will. He has 2 wedding rings. He wants to get married to 2 different people. That would make him happy. Chlorine would be happy with just 1 person, okay? So if these 2 teamed up, bam, bam, they could exchange wedding rings, but he still has 1 left. He still has 1 left. So he could have 1 lovely lady on his one hand, and another lovely lady, maybe her sister, on the other one. Not very good example, but it happens. Atoms don't care about morality here. They're atoms. They don't have a sense of morality or any issue like that. They basically just go around and do whatever spontaneity that they want. Just, they're crazy. But go with it. And her sister, I don't have room, but imagine if there's another one over here. Boom, Cl. She's a minus charge. Now there's plus and minus here. They balance each other out. Perfect. So now this guy is MgCl2. That is the formula. MgCl2, once again, magnesium chloride. Chloride, remember, negative charged chloride. Okay. Now let me back up one frame. We'll make it full screen again. Okay. So, first of all, naming these molecules, identify is it ionic or covalent? And then if it's ionic, what are the charges of each ion? Let's do a couple more challenging ones with us. Alright. Skip over that lady. Okay. So this is an easy one. I said more challenging, but we'll start easy. Go. So first of all, NaCl. Is it ionic or covalent? Well, if it's two nonmetals, it's covalent, right? If it's one of each, it's ionic. Na. Is it a nonmetal or a metal? Remember from the periodic table? Na was right here. Remember the staircase? Everything over here is metal. Metal. Okay? So we have a metal, automatically, it doesn't automatically make it ionic, but it definitely rules out this one. And since I asked the question, it's got to be ionic. Alright? Metal, chlorine's over here, non-metal. Alright. So what are the charges of them? Well, NaCl, Na. No, Batman, that spells sodium, right? Okay. Na. And I tell you they joke about sodium, but nah. Okay. So, Na has a plus charge. Got that? Because it's in the first row. This is all review. Cl has a minus charge because it's in the second to the last row. Okay, and in case you didn't know that. Hey, that's magic right there. My mistake. Circle, boom. Circle, boom. Okay, let's back up. Let's draw the valence electrons, the outermost electrons. Valence means outermost in this case. Na has one valence electron. I'm going to represent by dots this time because I want you to get used to both of them. Some people like dots, some people like minus signs. I do not care, as long as you can tell which is which. Alright? Now Cl. Remember how many dots it had? 1, 2, 3, 4, 5, 6, 7. Every single atom in the whole thingy-majiggy periodic table, they want 8. They want 8. They want 8. Shoot, I don't have another 6 finger there, but remember, 8. With the exception of hydrogen and helium. They want 2. But let's review as well. Okay? So, 1, 7. Once again, what's this going to do? This one is going to go here. So, green dot here. No green dot here. Okay? That green dot leaves, you lose a negative charge. If you lose a negative charge, you become more positive. So what's the charge of sodium? Plus 1. What's the charge of chlorine? Minus 1, because it gained another minus. It added a negative 1, if you will. This one minused 1, or lost a negative 1. Essentially added 1. Negative, negative, plus. Okay? So what do you call this? Well, first of all, how you name these is you name the metal first. Just name it as it is, like before. This was magnesium. We just said magnesium. Done. Okay? This one is sodium. So, sodium. Okay? Then, basically, you add the IDE, the ide, to the anion. So what was this one? Chlorine change it to ide. All right, chloride. Done. So this is sodium chloride. This was magnesium chloride. Now wait a second here. There's a problem here. This one is a NaCl. This one's MgCl2. Huh. Interesting. Well, that is why the charges are important, folks. Okay. Here's an example where you're going to have to use the charges to figure out the formula. Let's work backwards now. So, backwards time, rewind. Okay. Backwards time. Now we're going to start with the name and write the formula from that. Okay, working backwards, write the formula for potassium iodide. Making sense? This is all starting to click, hopefully. Potassium. What is the formula for potassium? If you remember from your element quiz, it is K. Got it? K. Hey. Alright. Now, sidetrack that. What is the charge? Oh, sorry, I shouldn't say charge yet. How many valence electrons does potassium have? You look at the periodic table, it has one. One valence electron. One electron in the outer shell. Valence means outermost shell. Okay? There's one. Okay. Now this is not K minus, this is an electron. Okay? One electron is outer shell. Iodide. You know what? I'm going to actually change this up a little bit. Oxide. Change it to oxide. Makes it a little bit more difficult. Okay? Oxygen. Oxygen, remember from your quiz, is O. O. Now, if potassium and oxygen got into a fight, it would end in a KO. Is that okay with you? Ha! But anyway, it wouldn't actually be KO. It would be something else, and we're going to see what that something else is right here. So, KO. Let's figure this out.